Welcome to this section where we're going to be taking a look at how to solve word problems using strip diagrams and then also algebra. In international tests, Singapore is often top on the charts. They're usually far and above other countries, and they use a curriculum that has kind of been dubbed in the US as Singapore Math, and a lot of it is built on strip diagrams, which are also sometimes called tape diagrams or bar models. And so I would guess that in your career as an elementary teacher, you will see strip diagrams, and they continue to kind of grow in popularity. They take a little bit to get used to, but once you get used to them, they really are really useful in comparing quantities and solving problems that at first some of you will say, hey, this is just easier to use algebra. But eventually in the more complicated ones, these will become actually easier than using algebra because you can really reason with pictures and diagrams. So let's jump into it. There's really two different types of strip diagrams. One is a part-whole model, and you can see you have a whole and then two parts. So we call this a part-whole model. The other is a comparison model where we have two things and we're comparing them vertically. Now, you do tend to look at them combined as well. So whether you set it up this way or this way really depends on the wording of the problem. And it's not something you need to teach your students like, oh, this is a part-whole problem, this is a comparison. But just ask them as they're setting them up, are we looking and we want one bar with a couple of parts, or do we want two different kind of bars that we're comparing? You actually, with Common Core standards, start to see this in first grade and really continues on throughout. It really starts maybe even like kind of foundational steps in kindergarten of looking at comparing the amount of apples and then using diagrams and then maybe a 10 frame here. You can see a couple of problems here. Let's just dive into it here. Sarah has 16 stamps. Mark brings her 4 more stamps. How many stamps does Sarah have now? Now, you might think of this as a comparison where you have a before and after. So Sarah's starting with 16 stamps, and instead of listing them all out, we use a bar and say 16. And then Mark brings her 4 more. So now we have 16 here plus 4 more here. How many stamps does Sarah have now? Now Sarah has 20. 16 plus 4 is 20. There you're like, well, that's just a word problem. Well, you're right, it's just a word problem, and you can do it without a tape diagram. That's fine. But it helps when we get into more unknowns or more variables. Example 3 here, Sarah brought 4 apples to school. After Mark brings her some more, so Sarah has 4 apples. Mark brings her some more apples. We don't know how many he brings her, but he brings her some more. And now she has 9 apples altogether. So at the end here, she's got 9. And so we can see, hey, if I take 9 minus 4 is 5, that tells me Mark must have brought her 5 apples. And you could see this is maybe a little bit more useful, or it really allows students to think forwards instead of backwards right at first. So I think that's helpful. A couple more here. Mateo has toy cars, 5 toy cars. Josiah has 2 more than Mateo. You see right away we're comparing here Mateo versus Josiah. And so we're going to compare. Mateo has 5. Josiah has 2 more than Mateo, so we've got the same here, and then he's got 2 more. How many do they have together? That was pretty poor. So 5 plus 5 plus 2, we could see that together they have 12. It also works for multiplicative reasoning, where we're working with times or multiplying proportions. rather than just adding and subtracting. So here, William's weight is 40 kilograms. He is 4 times as heavy as his youngest brother, Sean. What is Sean's weight? So again, we're comparing. We have William and we have Sean. Now, one thing you'll find as you start to make these, rather than just starting with a little picture, it's sometimes better to read the problem and think it through. Since William's 4 times as heavy as his youngest brother, Sean, we probably should start out with Sean's box being bigger. Because otherwise, when I take and find Sean's, it's a little more, I don't have quite as much to work with. Since William is 4 times heavier, we're going to have to break William's weight into quarters. So I'm going to cut it in half. Then I'm going to cut those halves in half again. That gives me quarters. So then I know that Sean's weight is 1 of those quarters. So now you can see William is definitely 4 times as heavy as Sean. What is Sean's weight? That's what we're trying to find. Well, we know William was 40 kilograms. And so if we divide that by 4, we get Sean's weight is 10 kilograms. Now, you might say, well, the picture actually took longer. I could have just done 40 divided by 4. And you're right. Students may not be able to. The other thing is this is really helpful to build for future work with fractions. So that's the intro on strip diagrams and how we use them. In the next video, I'm going to take a look at just